This video is part of a series where we build an entire FPV drone from start to finish. So if it feels like you're in the middle of a conversation that you missed the start of, that's why. If you're here for the information in this specific video, keep watching. But if you want to find out the full context for what's going on here, there's a link in the video description to the full playlist, and you might need to go back and start with video number 1. In this video, we are going to start assembling the quadcopter. We're going to put the frame together, we're going to put the motors on the frame, and we're going to put the ESC and the flight controller on the frame. And so the first thing I want you to do is open up the frame and find this frame plate. This is referred to as the mid plate. And I want you to find this metal X-brace, and I'm not sure if it's going to come to you in the packaging with these little wedges and screws already pre-installed or whether they're going to be separate. So if these little metal wedges and screws are separate, go ahead and install them as you see here. In your frame kit, you're going to find the 4 longest screws. On the mid plate, there are 2 sets of mounting holes for our flight controller and ESC. The flight controller and ESC together are known as the stack or the flight control stack, so called because they are usually stacked on top of each other. There are 2 common standard sizes for flight controllers and ESC. One has 30 millimeter spacing between the holes and one has 20 millimeter spacing between the holes. There are actually a couple other common standards, but they're a little bit less common. And this frame is only sized for 30 millimeter or 20 millimeter flight controllers. You don't have to do this, but if I get this flight controller out and just hold it up, we can see that this flight controller that we're going to be using is sized for 30 millimeter holes. So that is where we're going to put these stack screws. And what we're going to do is we're going to take this X piece and we're going to make sure that the flat part of the X piece is up against the carbon plate and the sort of contoured part is facing out. We're going to line it up with those mounting holes on the mid plate, and we're going to take our screws and we're going to insert them in the outermost set of holes so that we have 4 screws holding the mid plate, holding the X plate rather, up against the mid plate. There are press nuts in the mid plate that the screws will screw into. And when you've got that, you're going to take a driver and you're going to run those all the way down so that they are pressing the X plate up against the mid plate. The driver that you use will depend on the type of screw head you've got. These are M3 sized screws. If they are cap head like mine, you'll need a 2.5 millimeter driver. If they are button head, then you'll need a 2 millimeter driver. You're going to use the heck out of these drivers in this hobby, 1.5, 2, and 2.5 millimeters. If you're working with just like a set of Allen wrenches or hex wrenches, do yourself a favor, get yourself a toolkit that has an actual driver. It makes a big freaking difference. In fact, if you want a link to such a toolkit, I will put one down in the video description. There's actually a really good toolkit that includes a lot of the stuff that you're going to need to build and work in this hobby. I'll put a link down below. Once that's done, you should have something that looks like this. Make sure that you've installed the X plate with the little wedges facing the sides and not the front and back. Next, we're going to use our 2.5 millimeter driver and we're going to loosen up these wedges and we're going to insert the arms. And the arms go in like so. Oh, need to loosen it up even more. Arms go in like so. What I can do is I can take 2 of the arms and kind of wedge them in. And then once they are sort of wedged in there, I can just kind of tighten that down a little bit until they kind of are held in place. Don't tighten it all the way. We'll do that later. And the result should look something like this. Make sure that each of these 4 screw holes, 1, 2, 3, 4, lines up with the corresponding screw hole in the mid plate. Next, we're going to take this piece, which is called the bottom plate, and I want you to notice that there is this little channel milled into it here. That channel is going to go up against the X plate. It provides room for the screw head to go in. The bottom plate is going to mount like so, and you're going to see 1, 2, 3, 4 screw holes that will line up, and screws will go through the arms, as well as 1 central screw hole that's going to go here in the X plate. I think that the easiest way to do this is to take this little short screw, which goes through the center hole, and install it first. And just loosely install that. And you can see that we've also got room to manipulate the stack screws here, so that if we need to maintain the flight control stack or take those screws out for some reason, we can do that without disassembling the whole thing. So we'll just loosely install that center screw, and then we'll have these screws, which are going to go through this hole, and they're going to go through the bottom plate, through the arm, and through the mid plate all together. And they're going to be held in by a standoff. This is a standoff. It is threaded, and it will thread on. And again, you don't need to tighten it down super tight, but it'll thread on and sort of hold that together. Go ahead and do all 4 of these, 1, 2, 3, 4, exactly like that. At this point, here's what we've got. The base of the quadcopter frame is basically completely assembled. We've got the bottom plate, the arms, and the mid plate all joined together with the X plate in the center holding the arms in. We've got 1, 2, 3, 4, 5 screws on the bottom. We've got 4 stack screws sticking up through and protruding out, and we've got 1, 2, 3, 4 standoffs installed. Next, we're going to install the motors, and I want you to notice that the motors come with a set of screws and a nut. The nut is called a prop nut, and it's used to hold the propeller onto the motor. And what I like to do, just to keep from losing it, is I will go ahead and thread that on to the motor. Right now, just thread it on until you feel it start to grab a little bit. It has a little nylon insert to help keep it from backing off. So if you just screw it down until you feel a little tension, it should be pretty secure. The screws you should be extremely suspicious of. And the reason I say that is because these screws happen to be the perfect length for these arms and this motor. If you take a look at the motor base and the screw, you can see that the screw is, actually that screw could be longer. It actually isn't going to go all the way up through the motor base, but it'll get a few threads into the motor base and it'll hold, and that's fine. But the problem is that the motor manufacturer doesn't know how thick the arms of your quadcopter frame are. So when the motor manufacturer decides the correct length of screw to send, they have no idea if that's correct, so they just guess. And the problem is that if the screws are too short, then they just won't go into the motor and they won't grab, and then your motor might like come off in flight, which of course would be bad. But if the screws are too long, they will protrude up through the motor base and they will dig into these wires, the windings of the motor, and damage, basically destroy the motor. They can also, on some motors, come up and they can dig in here into these wires where they exit the copper windings. So whenever you're installing your motors on your quadcopter, you're going to want to check, just like I did. Stick the screw up through the arm, then hold the motor next to the screw and look at how far the screw protrudes into the motor. And if the screw protrudes up above the motor base by more than like a half a millimeter, then you should consider using a different set of screws, or you could use washers to kind of space the screw down so that it doesn't stick up. In your case though, you do not need to use the screws that come with the motors because the JB QAVS comes with a set of screws that are sized exactly right for its arms. So you're going to want to look in your frame kit, find the set of screws. They're going to look pretty much like this, except might not be the exact same length, but they're going to be cap head screws just like this. There's going to be 16 of them, 4 per motor, and those are going to be what you're going to use to mount the motors on your frame. The best way to mount the motor on the frame is to put one screw in, line up the base of the motor, and then just very loosely turn that screw in by hand. You're going to want to make sure that the motor wires are coming out and going up the arm of the quadcopter. So make sure the motor's facing the right way. Once you have one screw in, then you're going to kind of put the next one in, and again, just loosely kind of wiggle the motor around and get that screw to line up and loosely put that in. And then once you've got 2 of them, the other 2 are easy. After you've got all 4 of them loosely started, you can come back with your 2.5 millimeter driver and tighten them down. Be aware as you're tightening them down that these are steel screws and the motor base is aluminum. So if you crank it down super hard, you'll just strip out the aluminum and, well, if you strip one screw hole out, you can fly with 3 screws. But if you strip all the screw holes out, then you're boned. So don't do that. Get them nice and snug so that they don't back out. This is the part of the build where I acknowledge that some people would choose to use Loctite thread locker on their motor screws and the screws going up into the standoffs. That's cool if you're swing that way. Make sure you're using blue Loctite, which is removable, not red Loctite, which is permanent. And if you want to do that, that's fine. But I often skip it and just like to, just make sure my screws are snug. Now that the 4 motors are installed, we're going to go ahead and spread out the wires, remove those little twisties from the wires, and we're going to get the ESC. You remember the ESC, right? We're going to take the ESC out, and we'll set this box aside. We'll come back to that in a second. The ESC has a top and a bottom. You are currently looking at the bottom. The top is this side with all the copper solder pads on. That side needs to be facing up. Here in the 4 corners of the ESC are the mounting holes, and those mounting holes have in them silicon, we call them gummies. I don't know why we call them that. They are for vibration and shock isolation to help protect the ESC from being damaged in a crash. In mine, the gummies are already installed. Installing the gummies is a pain in the butt, and most flight controllers and ESCs come with the gummies loose in a bag, and you have to install them. I'm going to guess at some point in the future, someone watching this video will receive an ESC or flight controller with the gummies not installed yet. So I'm going to take one out and show you. Oh my God, they've done the right thing. Yay! Okay, so this ESC has a little cutout here, which makes installing the gummies super easy. Fantastic. Just slide them in there. Well, maybe based on that, at some point in the future, they will keep doing that at the factory instead of going, F it, that's too hard, and sending them to you loose. If your gummies are not installed, go ahead and install them. And then with the solder pads facing up, we're going to identify the front of the quadcopter, which is the side with these 2 little slits in it. Take my word for it, that's the front. We're going to turn the ESC so that I've got it upside down. We need this side facing up. We're going to turn the ESC so that these big 2 copper pads are facing the front, and we're going to put it down and press it down onto the mounting holes. But don't do it yet. I want to show you something. What I want you to see is that if I press this ESC all the way down on the stack screws, it is touching these metal press nuts that are in the mid plate. That's bad. There's 2 reasons that's bad. Number 1, if the ESC is touching the frame, then when the frame takes a hit, then the ESC could be damaged. But number 2, and more importantly, the stack screws are metal. The ESC is handling large amounts of electricity, and if metal is touching the ESC, the electricity can go where it's not supposed to go, and the whole thing will burn out. Whenever you're building this build or any build in the future, you always need to make sure that the ESC has a little bit of spacing from the frame so that it doesn't touch the frame or touch any screws or nuts that are sticking up off the bottom plate. The way we're going to handle that, there are various ways you can handle that, but the way we're going to handle that is that the ESC comes with a set of extra gummies, okay? And we're going to put those extra gummies on the screws underneath the ESC. So 1, 2, 3, 4. Now that we've installed the extra set of gummies underneath the ESC, there's plenty of spacing, maybe even more than we need. I'd say a minimum of 2 millimeters is what you're looking for. And everything is good and isolated and safe. Next, we have to connect the motors to the ESC. Each of the motors has 3 wires, and if you have some familiarity with electronic circuits, you might be thinking that one is positive and one is negative, and put all of that stuff out of your brain. 3-phase brushless motors don't quite work like that. It turns out that the way you connect these 3 wires to the ESC is that the 3 wires are going to go to the 3 pads on the ESC. I want you to think of this ESC as having 3 pads for this motor, 3 pads for this motor, 3 pads for this motor, and 3 pads for this motor. There are 12 pads, there are 4 motors, 3 pads for each motor. And the next question you might have is which wire goes to which pad? And it turns out that it almost doesn't matter. You can connect any of the 3 motor wires to any of the 3 ESC pads. And some of the ways you connect the wires make the motor spin clockwise, and some of the ways you connect the wires make the motor spin counterclockwise. You don't even need to think about this. It's not that it doesn't matter which way the motor spins. It totally does matter. The motors need to spin the right direction, which we'll talk about later what the right direction is. But for now, all we're going to do is we're going to lay the wires flat on the arm, and we're just going to solder the wires to the ESC 1, 2, 3. And it turns out if that ends up making the motor spin the right direction, fantastic. If it ends up making the motor spin the wrong direction, we can change that later in the process. A useful tidbit of information for you to know is that if you have a motor that is spinning the wrong direction and you have no other way to change its motor direction, swapping any 2 of the 3 wires with each other will cause the motor to spin the other direction. And sometimes you get in that situation where the easier ways that don't involve resoldering wires aren't available to you. You can always reverse motor by swapping any 2 of the 3 wires. Now we come to the part of the video that is going to cause a whole lot of people watching this to hit a wall. And I don't say that to discourage you, but just to be realistic about what's going to happen. You see, this here is a soldering iron, and the next thing we need to do is solder wires to the circuit board. If you already know how to solder, great, you're going to do fine. If you have never soldered before, this relatively expensive and fragile piece of electronics is not the place to learn to solder. I have a video which is all about beginner soldering specifically for FPV pilots. And if you don't know how to solder, unfortunately, I know this is not what you want to hear. You need to pause this video. There's a link to my soldering tutorial down in the video description. You need to spend a few hours getting minimally proficient at soldering so that when you solder on this electronics, you don't end up destroying it. From this point on, I'm going to assume that you've watched that tutorial, you've put in a couple hours of practice, and you're minimally competent at soldering. And I'm going to avoid giving a whole bunch of soldering tips, as tempted as I am to do it. So the first thing we need to do is cut these wires to length, and we're going to do that by laying them flat against the arm, just for neatness sake. I'm going to run this wire over to the pad that it's going to be soldered to, and I'm going to get my diagonal cutter, and I'm going to cut that wire just a little bit, maybe like 1 pad thickness past where the wire crosses the pad. I want to give myself a little bit of extra because I don't want the wires to be under tension, and I'm going to have to do a little work on the wire, and I'm going to lose some length to that work. So we should end up with something that looks kind of like this. It's hanging out over that pad just a little bit. I'm going to do that for all 3 wires. Pad number 1, pad number 2, and pad number 3. Next, we're going to strip these wires. I'll strip back about 2 millimeters of length. Twist that. When you solder, there's a chance that the solder will kind of spatter and throw little solder balls onto the electronics, and if solder balls get onto the ESC, it can destroy the ESC. If you don't feel 100% confident in your soldering, you can cover this with like a piece of masking tape or something like that. You can put a piece of cardboard or one of these little plastic bags over it, or what I like to do is just take the wires and move them well away from the ESC, at least while I'm doing the tinning. When you're soldering to the ESC, of course, you're going to need to be on the ESC, so maybe take that precaution. I'm going to tin this wire using my flux pen, which you totally learned about in that soldering tutorial that you totally watched. I'm going to add some flux. I'm going to tin, I'm just going to go ahead and tin all the pads. I'm going to need to do it eventually. And then I'm going to lay that wire down on the arm and kind of place it exactly where I want it. I have cut the wire to the correct length. The exposed length of tinned wire is just about the same size as the pad, and we're going to solder that down. So here's the first wire done, and you can see that it is laying straight on the arm. It has got just a little bit of slack, so it's not pulling on the ESC or pulling on the wire, and it's going to lay neatly, but it also doesn't have like a ton of extra wire laying all over the place. Having done that one, I'm going to do the remaining 3. I'll see you back here in just a second. Here's what it's going to look like when you've done all 3 of the wires from one motor. Notice the 3 wires are going straight and they're going to the 3 corresponding corner pads on the ESC. The next thing we're going to do is we're going to get some tape. You can use electrical tape if you have it. I like to use this stuff is fabric wire harness tape. This is not included in the kit. You will need to source this on your own. I'll put an Amazon listing down below, or I actually have a website, the Ultimate FPV Shopping List, which has a whole bunch of tapes, supplies, other things that I use. Anyway, I'll put links down in the video description where you can find it. We're just going to get ourselves the length of this tape, and we're going to tape these wires down. There we go. Having done one motor, I'm now going to do the other 3. I'll see you in a second. Here's what you should have when you are done doing all 4 motors. And don't throw out these wires. These are useful. You will have a use for them later. If not today, then someday. This is good wire and you should save it. Next, we're going to get these pieces that come with the ESC. This is going to be the battery lead. It's called, it plugs into the battery and gives power to the entire quadcopter. The specific connector that we're using is referred to as an XT60. So you hear people call it sometimes the XT60 lead. And if when you buy batteries to use with your quadcopter, you're going to want to make sure you buy them with an XT60 plug on them. If you're shopping at an FPV focused store, basically all the batteries that are going to work with this quadcopter will have XT60s on them. But if you're buying at a general hobby store, for example, there may be other types of connectors and they wouldn't work with this. And we're basically going to need to do 2 things with the XT60. We're going to need to solder these wires to the XT60, and then we're going to need to solder the wires to the ESC. And because this is a little bit different than the kind of soldering that was in the soldering tutorial, this is like a specific task, I'm going to give you some tips on how to do it and break my rule about not giving you soldering instruction. And the first thing I'm going to have you do is turn the XT60 so that the side with the plus and the minus is facing up. The other side isn't marked, and it's helpful to make sure you're getting it right by seeing the plus and the minus marked right there. The next thing we're going to do is we're going to come in with a tool, like this is a forceps, I think, but any kind of small pliers or anything, and we're just going to rotate these so that the little cups face up. These are just friction fit into the plug, and you should be able to just rotate them with a minimum of effort. And those cups being facing upward will help us with our soldering. And now I am using this fancy schmancy third hand tool. In fact, I've got a video about how freaking awesome this thing is. I'll put a link in the video description if you want to learn more about it. But you may not have such a thing. If you have any kind of third hand tool, you can use it. If you don't have a third hand tool, what I like to do is use this. This is called Blue Tack. I'll put a link to it in the video description below as well. It's linked on my Ultimate FPV Shopping List website, which is also linked below. And you can just take the Blue Tack and you can just kind of stick this in it. Easy peasy. I'm going to get my flux pen and apply some flux to the little cups, and then I'm going to tin these pads. And I try to more than just like lightly tin the pads when doing this joint. I want to get enough solder in this cup that it will complete the joint, and to do these 14 gauge wires you need a fair amount of solder. So I really try to fill the cups up with solder, and I think the easiest way to do it, pardon me, I'm left-handed, I have to turn this around, is to kind of feed the solder here and just apply a little bit of heat here, and then once it starts taking solder, just really get it in there and really feed it so you get a fair amount of solder that really fills up the cup. I am once again going to apply more flux because again these bigger wires are a little harder to solder. Now I'm going to get my red wire and I'm going to apply a little flux to it, and then I am going to put more solder on the red wire. And if you look closely, you'll see that this wire has already been tinned at the factory, but the factory uses lead-free solder, and lead-free solder is harder to solder. So I'm going to add some flux and add some fresh solder. Just really get that good and shiny. Once that's done, I'm going to bring them together, and I am going to, how am I going to do this? Probably this is going to be the easiest way for me. Now, that all went pretty quick, so let me talk you through it briefly. What I like to do is dry fit everything, get everything in place and ready to go. Apply heat. You will feel the joint become liquid because the resistance of the wire pushing against the dry solder will go away, and the wire will drop down into the cup. From there, you'll remove the heat, and then you will hold everything in place because it'll take a few seconds for the joint to cool out and become solid again. I'm going to do it again on the negative pad, and you can see it for yourself. With the black wire, a little bit of flux, extra clean, fresh leaded solder. And I'm actually going to do this one holding it with the forceps instead of the third hand tool, just to demonstrate a slightly different way of doing it. I'm not sure whether the third hand is better or the forceps is better. I kind of go back and forth. With the forceps, I can kind of maneuver it easier. I don't know. Oh, hang on. They're pressed up against each other. We're ready to go. We're going to apply heat, wait to feel it become liquid, and press it down into the cup, and then remove the heat and wait for it to become solid. When that's done, we should have something that looks roughly like this. The most important thing is that there is no bridging between the positive and the negative, that they are separate and distinct from each other. Actually, the most important thing is that the red wire is on the plus and the black wire is on the minus. Double check that at this point, and once you have confirmed that that is as it should be, then take this little black plastic cover, slide it up the wires, and it snaps into place here. Like so. Next, we're going to tin the ESC pads. You can let's add some flux. You don't always need flux just for tinning, but especially the ground pad on the ESC can often be very hard for people to solder to. You're going to want your solder at a pretty high temperature, and if you have a heavier tip, you'll want to choose the heavier tip on your soldering iron. Although you can see I'm just using a 2.5 millimeter chisel tip. You can get it done if you have a good, hot, high quality iron. We're going to tin both of these pads. We're going to need to feed a lot of solder in to get the whole pad covered. That is tinned, and we can add a little more flux since we've used some of it up in that joint. Don't be shy about using the flux. As long as the flux is no clean, you can see on my pen it says no clean flux. If your flux doesn't say no clean, you're going to want to make really sure you clean it off and don't use an excess amount, because it can cause short circuits when you power up for the first time. The way that you clean the circuit board, if you do have flux on, is you're going to get some alcohol and a soft toothbrush, and you're going to rinse it with alcohol and scrub it with a toothbrush. In fact, it might not be a bad idea to do that anyway once we're all done soldering, because if you have gotten any little solder balls on your ESC, scrubbing it with alcohol and a toothbrush will, even a dry rub with a toothbrush will get the solder balls off potentially. We are going to prep the XT60 plug, and what we're going to do is the XT60 plug is actually going to come out the side of the quadcopter. When the quadcopter is put together, I'll show you a little bit more why I decided to do it that way, but that's the way I like to do it. So what I'm going to do is I'm going to take these wires, and do you see right here, you can barely see it on camera, there's a little blue plus and a little blue minus. And that's telling us that this is the negative and this is the positive pad. So the black wire is going to go to this pad, the red wire is going to go to this pad, and what we're going to do is we're going to cut that black wire just a little bit short so that it all lines up correctly. So what we want is a situation kind of like this. You see, I'm going to go ahead and strip the black wire back, and we're going to do a little more than the normal sort of 2 millimeters. This is a pretty big pad, and we want the exposed wire to be about the same length as the pad we're soldering to. In addition, I'm going to cut the red wire back just a little extra because you can see it's only got just a very little bit exposed, and in this case I'd like to get just a little bit more. A little bit of solder. And then I'm going to start with the black wire and then lay the red wire over the top of it. So we're going to take the black wire, we're going to put it sideways out the side of the quadcopter, and we're going to solder that down. Respect. Not bad, not bad. If that went easily for you, congratulations, that's the hardest solder joint in the whole job for most people. When we put the red wire down, it is really important that it not make contact with the ground pad. So make sure that the red wire is far enough over that only the insulation of the red wire has any possibility of touching the negative pad, because if positive and negative come together, you'll get a short circuit and the fire will come out. Then it'll be bad. Oh, that didn't hold it long enough. I got impatient. Kind of want to use this. I don't like using my fingers. Gosh dang it. Okay, there we go. The result may look something like this. Notice that my red wire insulation is covering thoroughly the black ground pad. There's no potential for bridging between them. The solder is distinct. There's no short circuit there, and we're ready to proceed. The next thing to do is install the flight controller above the ESC. Just like when we put the ESC on, we had to get some spacers to make sure it didn't touch the frame. There's a little bag that comes with the flight controller, and in there are some additional gummies. And, oh, there's plenty of them. There's lots of them. We're going to put those gummies 1, 2, 3, 4 in between the flight controller and the ESC to keep them from coming into contact. And then we're going to take the flight controller, and I want you to notice that on the top of the flight controller, which is the side we're looking at now, there is this little arrow. Every flight controller, well, I guess I shouldn't say every, but almost every, if not every flight controller will have a front-facing arrow on the flight controller. And that indicates that this direction of the flight controller is intended to face the front of the multirotor. You don't have to do it that way. If for some reason you needed to not make it face that way, there is a way to configure the flight controller to know that it's not facing front. But by default, it expects to be facing the front of the quadcopter. And if it isn't, then when you try to fly it, it won't fly right. It won't fly at all. It'll just freak out and flip over. So we're going to identify the front of the aircraft, which is got these two little slits for the camera plates. And of course the ESC, the XT60 is coming out the front. And we're going to line that up with the front-facing arrow on the flight controller. We're also going to get these wires that come with the flight controller, and they're going to connect the ESC to the flight controller. The plug on the flight controller that goes to the ESC is this one, and there's only one plug on the ESC. That's how they're going to get connected together. And you can see that those two plugs are very close together, so we can use the short one of these wires to connect them. As you plug this in, bear in mind that there are you can see these little tabs right here that only let it go in one way. You can force it in the wrong way, but if it seems like there's resistance, don't force it, just flip it over, and that may fix it. Once it's plugged in, we can do the same thing for the ESC. You can plug that in. There we go. And then what I like to do is just give them a couple gentle twists to take the slack out. It's not mandatory, but I think it helps keep things neat. Don't over twist it and put tension on it though. And the result will look something like this. A note about connecting ESCs to flight controllers. In this case, the ESC and the flight controller are both manufactured by the same company, and they're made to go together. And what that means is that you can assume that the wire going between them will work. But if you have ESCs and flight controllers made by different manufacturers for some reason, you cannot assume that the plugs between them are compatible. The order of the pins in those plugs is not standardized between manufacturers. And if you have a wire that you just go and then you plug in a battery, you could fry the flight controller. So as long as you bought the ESC and the flight controller, from the same manufacturer in a kit made to work together, it's probably safe to just plug them in with the included wire and be good to go. But if you're ever in a situation where you're mixing and matching, you need to know how to make sure that things are good. But that's not going to be a topic for this video. This is quite an accomplishment. We have built the bottom part of the frame, we've installed the motors, we installed the ESC, we soldered the motors to the ESC, and we installed the flight controller. That is going to do it for this video. In the next video, we're going to do a very important test that makes sure we haven't made any dumb mistakes that are going to cause something to fry or blow up. I'll see you there. As a reminder, there's a playlist in the video description with all the videos in this series, and I'm putting a card on screen. If you can see the card, great. If not, head down to that playlist and head to the next video in the playlist.